In this video, we will discuss further about the x-intercepts of quadratic functions. And don't forget, the general form of the quadratic functions that we use is y equals ax squared plus bx plus c. And from here, if we want to go further to x-intercept, we need to learn first this powerful tool, which is discriminant. The discriminant equals to b squared minus 4ac. The b is the coefficient of the x, and a is the coefficient of the x squared, and the c is the constant. Okay, there will be four possible conditions of x-intercept, the number of the x-intercepts based on the value of the discriminant. The first one, we have two rational roots. It means that this quadratic function will have two values of x-intercepts, and the value itself will be rational numbers. Okay, in this case, two conditions must be satisfied. The value of the discriminant must be positive, and it must be a perfect square. So let me remind you that the perfect square is a value that if you square root it, you will have another integer. For example, 4 or 9 or 100. These are examples of perfect square. Okay, so whenever the value of the d is the positive and the perfect square, you will have two values of x-intercepts for your quadratic function, and it must be rational numbers. So the second one will be two irrational roots. It means there will be two values of x-intercepts, two different values of x-intercepts, but the values itself will be irrational numbers or radicals usually. So the condition that must be satisfied is the d must be positive, and it is not a perfect square. So for example, the value of d equals to 5, 13, or 12, or any non-perfect square. Okay, this will cause two irrational roots. The third condition is only one x-intercept. Okay, so the parabola has only one x-intercept, and the value itself will be rational number. The only one condition that must be satisfied is d equals 0. And the last one, there will be actually no x-intercept. So no x-intercept on the real plane, but of course we have to accept that actually there are two different imaginary numbers for your x-intercept. Okay, so on the graph we can say there is no x-intercept, but actually we still accept that the value itself will be imaginary numbers. We will go further in this later sections about this. So the condition that must be satisfied is the value of d is less than 0. Okay, so yeah, this is the graph. Okay, this is just a sketch. So the first, this one, okay, this one, there are two different parabola. This is facing upward, this is facing downward. Again, the one that determines it is facing upward or downward, it's based on the value of a, right? So if the a is positive, it must be facing upward. If the a is negative, it's facing downward. But this one, both the facing upward and facing downward, this has two x-intercepts, but it's not really can be shown that whether it is real rational numbers or irrational numbers. So for this case, the thing is the value of discriminant must be positive. D is greater than 0. Okay, but the one that differentiate whether they are rational numbers or irrational numbers will be if the D is a perfect square or not. Okay, so this will be the graph of a discriminant which is positive value. And for this one, you can see that the vertex is right on the x-axis. This one, the vertex also right on the x-axis. It means the intersection to the x-axis is only 1. So we have only 1. And this graph is a graph of a quadratic function whose discriminant is equal to 0. Okay, and the last one, this one, the quadratic functions don't have x-intercept. This one is facing upward without any x-intercept. This one is also facing downward without any x-intercept. So these quadratic functions must have the discriminant less than 0. Okay, that's how you see it. So yeah, this is clear. This is only explains about a graph which facing upward, and you can see that this one has only one value of x-intercept. This one two different values of x-intercept. This one is no x-intercept. So this one, the d equals 0. This one, the d is greater than 0. And this one, the d or discriminant is less than 0. Next question is how to find the values of the x-intercepts. In this video, I will introduce you two methods. The first one will be factor completely and find the zeros or the roots. Later, I will show you what is the zeros and the roots, but of course, we have discussed this from chapter 1. Okay, so the restriction. This method is limited only for factorable quadratic polynomials. Again, so if you cannot factor the quadratic polynomials, don't bother to use this method. Okay, since of course the method itself is factor completely. It means you have to be sure whether your quadratic polynomials can be factored or not. So how do you know? We have the discriminant as the powerful tool to check it first. So you can check your quadratic polynomials whether it can be factored or not by using the discriminant. So if the discriminant is positive and a perfect square, it must be factorable. Or if the discriminant equals to 0. Okay, so let me just give you an example. Find the x-intercept or x-intercepts, since we don't know how many x-intercept we will have. Is it 0, 1, or 2? Of y, x squared minus 15x plus 56. So before we decide whether we will use this method, factor completely, we need to check whether it is factorable or not by using the discriminant. So the discriminant b squared minus 4ac, you just replace it, replace all b, a, c by the components there, the numbers, and then you will have the value for this one is 1. 1 is a positive value, a positive number, and it is a perfect square since 1 equals 1 times 1. So since it is 1 and it is greater than 0 and a perfect square, it means we will have two different values of x-intercepts, and they are rational numbers. Since they are rational numbers, therefore these quadratic polynomials can be factored. Okay. Let's solve it. Let's find the x-intercepts. And you can see that first we substitute y by 0 since we are looking for x-intercepts. And since we are certain that this is factorable, use your factoring skill and we will find the factors will be x minus 8 and x minus 7. Okay, and then let's find the zeros or the roots. The zeros or the roots are the value of x that if we replace the x by that number, the factor will become 0. Okay, so for this one, from this factor, the 0 will be 8. Since if we replace 8 here, this factor will be equal to 0. And from this factor, the 0 is 7. Since if we replace x or substitute x by 7, it will become 0. So we have two zeros here, 8 and 7. The conclusion, the x-intercepts, there are two different values of f of x-intercepts, and they are 8, 0 and 7, 0. Let's go to another example. Find the x-intercepts of this quadratic function. So before we bother to factor it, let's check whether this polynomial can be factored or not. So by using the discriminant, and I just substituting all of the b, a, c by the numbers that we have known, and then, well, it's 0. Okay, since it is 0, it is it satisfies this expectation and it is factorable. And you have to keep in mind that if the d equals 0, it means we have only one value of x-intercept, and that value will be rational number. So since it is 0, let's just find the value. We substitute y by 0, and then using your factoring skill, we can see that there are two same factors here. Okay, two same factors. It means we have only one 0. The 0 that will make this factor is equal to 0. That will be 5/2. So yeah, there's only one x-intercept. Therefore, the x-intercept is 2.5, 0. Yeah, 5/2 or 2.5. Yeah, that's how you use the first method. The second method is the quadratic formula. So let me just present you what is the quadratic formula, and you have already been exposed to this in the 8th grade. So I want to separate this. So usually we use the plus minus thing, but I want us to be clear that since we are finding the x-intercepts, we are open to the possibilities there are two x-intercepts, or maybe one, or maybe 0. So the first x-intercept will be minus b plus, and then so on. And the second x-intercept, this is minus. Okay, so again, yes, we can combine the statement and simplify it into this. So x1 and x2 equals to negative b plus minus square root of d, since b squared minus 4ac is the d itself, discriminant, over 2a. So let me show you an example. Find x-intercepts of this one, which we have already found it by using the first method, this one. So we have used the first method, and as you can see that the quadratic formula, there is no restriction. It means it is more general. So it can be applicable to any quadratic function. Okay, there is no restriction. For example, this one, of course, we know that this one can be solved or can be found, the x-intercepts, by using the first method. But how if we use the second method, which is the quadratic formula? So let's just use the formula for the first x-intercept. I use plus here, and let's just substitute b by negative 15, a by 1, and c by 56. In the end, you will have this statement, and let's simplify it, and it becomes 15 plus square root of 1 over 2. Square root of 1 is 1, so it's 16 over 2, and it is 8. That is the first x-intercept. The second x-intercept is by using the subtraction. So let me just go directly to this section, since it's always the same, right? So it's the difference only this subtraction, and we have 14 over 2, and it's 7. So yeah, we have the same result. The x-intercepts are 8, 0 and 7, 0, the same. So yeah, the second method is a general one. It's more so it is again applicable to all quadratic functions. So let me go to the next example. Find x-intercepts of this one. So it's always suggested that you check the discriminant first, because we want to know how many x-intercepts that we are dealing with, and we want to know which method that you can use. If yeah, of course, for the second method, quadratic formula, it's not mandatory to find the d, since you can use any value of discriminant for quadratic formula. But again, let's just check it. For this one, the d equals, okay, let's just you can substitute everything, and we can find it is negative 303. Since the discriminant is negative, remember, we have no x-intercepts since we are dealing with the real plane. But of course, we have the values of the imaginary numbers. But that's for later. It means there is no real x-intercepts, and you don't have to be bothered to find the x-intercepts for now. Okay, let me get this clear for now. Later, after we discuss further about the imaginary numbers, you have to find the values of the x-intercepts, although it doesn't exist on your graph, but it exists on the imaginary plane. Okay, so let's go to the next example. Find the x-intercepts of this one. Okay, again, always checks the discriminant. And by checking the discriminant, we have the discriminant is equal to 204. And 204 is a positive one. It means we have two x-intercepts, but it is not a perfect square. It means this one cannot be solved, or you cannot find the x-intercept by using the first method because it is not factorable. And the last result, the values of your x-intercepts must be irrational numbers. It must be in radicals. So let's just, yeah, this is a positive and not a perfect square. So let's just use the quadratic formula, and just as usual, you replace the a by 2, the b by 2, and the c by negative 25. And in the end, you will find this. And the expectation for the final answer, you have to simplify it. But since we cannot use the calculator, I want you to simplify the radicals. So always practice to simplify the radicals. When I simplify it, square root of 204, it becomes 2 times square root of 51. And then I can cancel 2 both on the both terms on the numerator by 2 on the denominator. And this is the simplified form of the radicals. But of course, if you have to plot this on your graph, find decimals value. Yeah, it's okay. Yeah, of course you cannot graph negative 1 plus square root of 51. But for the calculation purpose, this will be your final answer. And for the second x, I use minus here, and it's all the same. And then this is the final result. So actually, we have two different x-intercepts, but the value are irrational numbers, right? And if you try to use your calculator to count this one, it will be an endless decimal. But yeah, it's still real numbers, and they exist on the real plane. So there you go. That is how you find the values of x-intercepts by using two methods. Again, it depends on the instruction, whether you are instructed to use the first method or the second method. If it is not instructed, you are free to use the first method or the second method, but keep in mind that for the first method, it is limited. It is only for discriminant positive or zero, and the d must be a perfect square. But the last thing is, let me show you some examples. Okay, and this equation, this function, we can see that the graph, by referring the graph, it has only one x-intercept. This one has no x-intercept, and this one has two x-intercepts. Okay, and this one has one x-intercept, this one has two x-intercepts, this one has no x-intercept. There is a function there. If you want to check it by yourself by finding the discriminant, that's good. But the thing is that I want to recall is the axis of symmetry. As you can see that on the vertex, if you draw a vertical line, this is the axis of symmetry, or the line of symmetry, or the mirror, right? And if if you are asked what is the equation of the line of symmetry, of course you can know that it is x equals something, right? Since it's a vertical line, it depends on the value of the x. So for this one is x equals 3, this one is x equals 0, and so on. So yeah, I'm just adding, or if you are asked about the equation of the line of symmetry, we are just referring to these vertical lines that is passing the vertex. That's all for the second part. Thank you for watching.